Hello developers, let's start developing. My name is Veko and today we're gonna take on the 14th task of the Advent of Code 2021. First time I see this task, I didn't cheat this time, and let's see what we're having. Yeah, I guess that... Oh no, we need to do some kind of regular grammar, I guess. So this is the string and these are the substitution rules and we need to do something with it. That's my fill. Yeah, the other word for that can be used is polymerization. Strain on your submarine. The submarine has polymerization equipment that would produce suitable materials to reinforce the submarine. Necessary input elements. Finding the optimal polymer formulas. You have a polymer template and a list of pair insertion rules. Pair insertion process a few times. So we are starting with NNCB, and then we have some rules when we can change something with something else. So we will need to find which rules are applicable. One rule that I'm seeing that is we can, I guess, change the NC with B, for example. Oh, we should not change NC with B, but we should change NC with NBC. The insertion all happens simultaneously. All three pairs. So we have a rule NNC, we have a rule NCB, and we have a rule CBH. Yeah, it overlaps. So after the first insertion, we are inserting 3 items. So this thing essentially doubles after each insertion, after each step. Okay, we will need to think on this a bit, especially in the sense of the second part, because I sense that the second part will be what will happen after 100 steps. And if this thing doubles, after 100 steps, we will have about 2 to the 100. Okay, even if it's 2 to the 95th degree, that's more bits and bytes that I have in my computer. But for the first part, I think that we should start with no optimization and we should start basically with straight up simulation. And maybe we will get some insight into how everything goes. So again, we need to read the lines. This is lines and this is read input lines for this day. And then we can take the start polymer. That's the polymer, that lines of 0, lines dot skip. No, regular skip, I think. Actually, we call that slicing. JavaScript, and then we need to map. And from what I saw, we always have, and by the definition it's kind of obvious that we always have this exact format. Something and an arrow to 2 letters, arrow, 1 letter. So that would mean that we need to get the first 2 letters. That's the what should we call that? What should we call that? That's the source and target. Let's do that. Line dot slice or substring starting from 0 and ending at 2. And target will be line of substring starting at 0, 1, 2, 3, 4, 5, 6. 6. And ending at 7. And these are the rules, the substitution rules. And let's just define this as the interface that we have. So we have a polymer and we have the rules. If we need a rule interface, we might need it. Yeah, it's this. Let's format it a bit better. Nobody's charging us by the line of code, so we can do this. So the rules are an array of rules. And this means that if we return polymer and rules, we are golden. We just need to change this, that we're not getting an input array, a number array, but we're getting an input object. As always, let's make sure that we're actually getting the input correctly. If the input is wrong, everything is wrong. Polymer is NNCB, this is the source, this is the target. Yeah, that is okay. Now, when I think of this, I think that the rules might be better if we have a kind of a different structure. Maybe not an array of source and target, but what happens, because we're gonna need to have it as a lookup table. Do I have a method called toHash or toHash? Yep. And hash has 2 parameters, and then I need a selector and a processor. Yeah. So the selector will take the source and the processor will take the target. Let's have it like this so we know what it's got. So what we're doing now, we're just changing this into an object that will be a bit on the different side, and so the role is actually, we won't have this, but the rules is an object when the key is a string that returns a string. So that's do I have this as a type? Yep. Yeah, this is a hash of strings. Let's take the input, and once we see the input, I think that I can explain what the hash is better. Yeah, as you see, the rules now have all the entry or the source strings as keys, that so that we can do lightning fast lookup, and all the Outputs are basically the other type of the value. Okay, that should be it for the input parsing. Yeah, we are taking some 6 milliseconds for that, but 6 milliseconds for that and for displaying it actually, but okay, if that is the problem, we're gonna add it. So now we have our input. Let's see us do one step. I'll copy this over. So now we need to do, I will create another function. No, let's just execute step, where we have our polymer, and we have our rules, and we are returning a string. This can be like this. Yeah, it says maybe you want to actually call part 1. No, I want this to be called by part 1. So what we need to do, we need to start with the polymer, and go up to the penultimate character in it. So we need to run a loop for our starting. We need to loop 0 to 2. So we need to start with n, so we can get nn. We need to start with this, so we can get nc, and we need to get this, so we can get cb. Yes, index plus 2. So we're starting with that up to, but not including the second one, so we're getting 2 characters. If the rules contain such a key, we need to do a 2 passes here, because if we change now, yeah, let's have that. We can say just this, insertions, add to the insertions, rules of key, if we have that, if we have it, or if we don't have it, just put in an empty string. Because if we don't have such a rules, we basically don't need to insert it. Let's console.log the polymer and console.log the insertions. Let's execute a step, execute a step, execute a step, and that will take the polymer and the rules. And see what happens. If I'm correct, we should get an array of 3 items that will have the insertions that we need to do. C and B and H. Let's see if that is somewhat correct. C and B and H. And now we basically need to join that. So another for loop. And we need to construct a string. This is gonna be a bit slow. Okay, we're ignoring performance for now. We're ignoring all kind of optimization because to get a string of some thousand-ish lines, it's not an issue. Of course, we will think on that most likely for the second part. So we will need to do we will need to do one from the polymer and one from the insertions. So polychars is polymer dot split on each character, and this is the output. That's an empty array. So for each and every item from this we need to do output dot push one of the polymers and output dot push one of the insertions, and once we're done we need to just console log this, and if I'm calculating correctly we should just be missing the last character of the polymer because we didn't do that. So the polymer was N and CB, N and C, and we have the H which was the last insertion, and we're just missing B, so we can just say output dot push the last one, and then we can say return output dot join on an empty string, and this will get us the output as a string. It would have been nice if we actually log that. So we started with this and we've gotten this. Let's run 3 more steps. Actually we can use polymer all the time. One step, log the output. 2 steps, 3 steps, 4 steps. So this is the second. This is the third. And this is the fourth. And I'm quite confident that this kinda makes sense. So this means that we can do 4 run. That's between 1 and 10. And we don't actually need the value, we just need to do this. And let's see how long this thing is. Marshall. This is a huge strings of N's and B's, and we can do some analysis on this string that we have some patterns that we're actually we can identify maybe. And we might need to use that for things like that. If we manage to have this running 30 times, let's say, let's start with 20, and just give me the length of the polymer, because the polymer itself is gonna be huge. Yeah, this is something like 3 million characters for 20 runs. 30 runs will give me something like 3 billion characters, which is a lot of memory. So I'm not gonna do that. So now what we want to do, we want to have the polymer to transfer this to some kind of a histogram. Let's do it this way. I think I might have some ready-made method, but I'm not I actually think 2hash will be able to do this. This is not a hash, this is more of a lookup. Do I have to histogram? No. Yeah, histograms are usually hashes, but I will just create one, and then we can say for, yeah, run through the, and this is the beauty of Copilot. Since this is called histogram, usually that's exactly what I want to do, to create a histogram. And this is how you create a histogram. I'm looped through all of the items, and I'm not taking this as a substring. I just need the polymer of index. I just need the specific character, and the histogram of that character should be either the existing value, or if I don't have an existing value, set it as 0 and add 1. If I look at the histogram, here it is. We have 1707. Let's see, B occurs 1748, 1749. N occurs 865, 865. C occurs 298, 298. H occurs 161. I don't need this -1, obviously. Eight 65, 1649, 1749, 298, 298, 161. Okay, so we need to get the most common element and the least common element. And in order to do that, now that we have the histogram, we can transfer the histogram into an array. We can get object.entries of the histogram, and this object.entries actually returns you a array of tuples, so that each element has a thingy, so to say. Each element has a tuple with the name of the key and the value of the key. Yeah, we can say that, yeah, I know that you have no idea what it is, but this is actually a number. Yeah, because object entries has no idea that our histogram is actually a number map. I think that I can even define it like that. Hash of number. So that means that it only has a number. So, and we can sort them out, and actually let's console log this, so we can see what we are getting. So we will have an array, and the first element is B, the last element is H. So this is the frequencies array. I don't know why I ate this up. And I'm just gonna do this. Return the first one minus the last one. In our case, that is B minus H. And that is 1588, which is exactly what we wanted. Let's see this thing. This run for 4 milliseconds. I'm expecting this to run, I don't know, 10 times as slow. No, something like that, but 7 or 8 times as slow. And it seems that our answer is this. Yeah, this is the right time. Now, let's see. I think that we're gonna be asked to get the number after 100 iterations. Oh, it's just 40. Yeah, and we need to do the same calculation afterwards. Well, yeah, this is a hard problem, and this is a problem that I will return to in a minute, because I will have to actually pause this here, because for one, I do have a real life, so I will have to take care of that, and the second part is that I might need to do some thinking on this.